Alright, so I had sent the. Okay, Arjun will also not be able to join. So I had sent the topics that we're going to cover today. So primarily our topic would be whatever we'll do will be more related to unit conversion and percentage related problems. And if I teach you guys how to do unit conversion and percentage, you guys will probably laugh at me. That's why we'll focus more on the word problems related to these topics. So that way we will quickly touch upon the concepts and then we'll try solving as many problems as we can. So that way you actually get a feel of the type of problem that you're going to deal with rather than just talking about the basic concepts. Okay. So we talked about the different types of units or the system of units that we deal with, right? When it comes to measuring volume, weight, length, and then time. And we talked about the metric system and the reverse customary system. So we'll not go into that conversion, but we'll not go into the basics of that because we have covered that part. Let's deal with some of the sample problems or sample word problems related to that so that we can at least experience what kind of problems we'll deal with and then how prepared are we for solving those problems. So again, like I always bored you guys with my method of solving problem. Who wins the gold medal? Gold medal depends on how he or she ran in the race. Read, analyze, and then Nike. Just do it. So let's look at the first problem that we want to deal with. Here, hello Neil.
Hi.
Where is Sarah?
Oh, she's coming.
Okay. So we are just starting. So we are dealing with some of the problems related to unit conversion. Hello Sarah. And then we'll talk about few word problems related to percentage. Hello. Okay, so I'm reading the question for you guys. A high school class is measuring the amount of nitrate in a local stream. A high school class is measuring the amount of nitrate in a local stream. Okay, that's a good information. They are measuring the amount of nitrate in a local stream. To be considered safe to drink, the maximum amount of nitrate that can be present in water is 10 milligrams per liter. Now, hi Deep. No worries. But you seem to be talking from a distance. Okay. Alright. Hello Chris.
Hi sir, sorry for being late.
No worries at all. You have not missed anything so far. We just started. So I have picked up the first problem. So today's class, just for the kids who joined a little late, we are going to talk about unit conversion and percentage. And again, these two concepts I'm sure you guys have learned probably 3-4 years ago. So you know it. We are going to deal with the word problems related to these topics, which is part of the syllabus for us, and see what is the level of problem that we are going to deal with and how we are able to solve them. Okay, so I'm reading the first problem right now. The problem is a high school class is measuring the amount of nitrate in a local stream. To be considered safe to drink, the maximum amount of nitrate that can be present in water is 10 milligrams per liter. To be safe to drink. I'm just, as I'm reading, I'm just noting it down, okay? So I'm not solving it yet. To be considered safe to drink, the maximum amount of water, maximum amount of nitrate that can be present in water is 10 milligram per liter. The class takes a sample of 15 liters. 15 liters. The class takes a sample of 15 liters of water. If the number of milligrams per liter of nitrate in the stream was 3/4 of the maximum that is safe to drink, how many milligrams of nitrate should the class expect to find in their sample? Okay. Now the word problem is kind of trying to, or somebody whoever has put the question here is trying to get us confused. So let's read it again. This is our thumb rule, right? A high school class is measuring the amount of nitrate in a local stream. Okay, somebody is measuring, that's fine. To be considered safe to drink, the maximum amount of nitrate that can be present in water is 10 milligrams per liter. So this is considered safe to drink, okay? 10 milligrams per liter. The class takes a sample of 15 liters, okay? I'm stopping there. The class has taken this many liters of water. If the number of milligrams per liter of nitrate in the stream water is 3/4 of the maximum, that is safe to drink, how many milligrams of nitrate should the class expect to find the sample? So the options given are 112.5. This is A. Second option is is 150. This is 112.5. This is 150 milligram. C is 200 milligram. And D is 225 milligram. And I will not try solving it. Only thing I will do is, I will read this question one more time for you guys, and I would request you guys to try solving it and then see what is the comfort that you guys have for solving this problem, and if anybody gets stuck, I'm here. I'm reading the question one last time. A high school class is measuring the amount of nitrate in a local stream. To be considered safe to drink, the maximum amount of nitrate that can be present in water is 10 milligrams per liter. The class has taken a sample of 15 liters of water. If the number of milligrams per liter of nitrate in the stream water is 3/4 of the maximum that is safe to drink, how many milligrams of nitrate should the class expect to find in their sample? Somebody got dropped off or somebody joined? I think somebody got dropped off. Okay. So you all heard the question, right? This is a summary of whatever was in the question. 10 milligrams per liter is considered safe for drinking. The kids have taken 15 liters of water as sample, and if they found the amount of nitrate per liter is 3/4 of the max that is considered safe, then how many milligrams of nitrate they found in their sample? Vishal, you heard the question, right? Everybody heard the question, I am assuming. Yeah? So I would want you guys to give it a shot and tell me what is the answer that you are leaning towards, and I would be interested to understand how did you approach the problem. So once all these dots are connected, then we'll move on to the next one. Yes, Vishal.
Are we trying to find how many milligrams or what the 3/4 the max is?
No, so the question says this is the safe, this is the amount of water that they have taken for sampling, and the class found the amount of nitrate in the water was per liter was 3/4 of the maximum that was considered safe. How many milligrams of nitrate they are talking about? So the question is to find out what is the total milligrams of nitrate present in the sample that they had taken. You got the question right, Vishal?
Yeah.
Okay, yeah. Okay. I got one answer. I heard it. I'm not saying it. I don't want you guys to get biased. I want to hear 2 more answers before I move on to try solving it. Can I assume everybody will give it a shot? Neil, Sarah, Rehan, Dave, Dhanvin, everybody? Yeah, Vishal.
I think it's C.
Okay. Your answer was? First. Okay. So I got 2 answers. That is good.
Mine is also A.
Yours is A. So 2 A's, 1 C. How about you, Neil?
I think it's A.
Okay, Neil says A. So we have 3 A's, 1 C.
Oh, my bad. I also got A because I
no.
forgot to do 3/4 of 150.
Okay. All right. Anybody who is still trying to figure it out, or Rehan, Dave, what is your answer, beta?
Sir, I got A.
You also got A. Rehan, how about you?
I got A too.
Oh, you also got A. Man, there's nothing for me to do now. The teacher is becoming redundant then. Everybody is getting A. But you know what? I'm a very bad teacher, like I always claim. I don't trust anybody. Unfortunately. And I mean, obviously I trust you all, like my own kids. But yeah, when it comes to math, I change my hat. So let's see, Vishal, do you want to explain what did you do? I mean, just tell the approach part of it, not the solution. I am not interested in the calculation. I'm interested in this approach. What did you do?
So first, 10 milligrams is equal to 1. So I multiplied 10 times 15, which is 150, and I found 3/4 of 150, which is 112.5.
Okay. You did the same thing?
I took 10 and multiplied by 3/4.
Uh-huh.
That gave me 7.5 multiplied by 15.
Okay. So yeah, it is like A times B versus B times A kind of a scenario. So I'll just repeat myself, okay? And I might sound a repeat telecast of what Pranit and Vishal explained, and I'm sure everybody did the same way, a similar way. When I read this question, right, I read the question so many times that I got you guys bored and tired, and that was purposeful. Question said, okay, what is considered safe to drink is 10 milligrams per liter. That is what is considered safe. And then says that they took a sample of 15 liters. And then the question says that if they found the amount of nitrate in water was 3/4 of the maximum that was considered safe, tell me how many milligrams of nitrate they found in their sample. Meaning, if they were taking this much of a sample, how many milligrams of nitrate they actually could extract from the water or they could find in the water. Approach will be simple. This is what is considered safe. And what they found was, this was the ratio they found. Meaning, if 10 milligrams per liter is found safe or considered safe, they found 3/4 of that. Meaning, it was even safer. Safer than the maximum allowed concentration. So, you can say, okay, so that means they, instead of finding 10 milligrams per liter, they found 3/4 of 10 milligrams per liter. So this was the amount of nitrate they found per liter. Now if they have 15 liters, multiply that by 15. If they took 20 liters, multiply that by 20. So that is one approach, and like what Vishal did, he said, okay, fine. This was the safe limit and they got 15 liters. So if it was, with the maximum limit, they would have got 15 times 10, this many milligrams. See the unit, they calculate some units, right? This is 10 milligrams per liter, and this is 15 liter. We multiply numbers or divide numbers and we deal with them. Here you have units also. See, you can do tic-tac-toe with the units also. 10 milligram per liter. This was the concentration per maximum, and you got 15 liter as sample. So number you will multiply. Can you multiply unit with the number? No, you cannot. You will deal with the unit separately. So here you have milligram per liter, and here you have liter. This liter gets knocked off. What you are left with? 10 milligram. So 10 milligram into 15, that is 150 milligram. This is what Vishal was saying. So had it been the maximum limit, he would have found this much. But the question says the students found this to be 3/4 of the maximum. So 3/4 of the maximum. Had it been maximum, that it would have been 150 milligram, but they got 3/4 of that. Put that in the calculation, and that is what you got. So everybody got the right answer. There is nothing for the teacher to do. Good job, everybody. Okay. Let's move on to the next one. So there was nothing complicated about it, right? But see, what I'm trying to do, or what my purpose here in the class is to make you guys believe that there's not even a single question that is supposed to be difficult. It is us who make it difficult. And what did we do to make it less difficult was, when you saw me bothering you guys by repeating the question again and again, when you read the question again and again, you saw that the onion started peeling off one by one, right? Make sure that you guys are using that technique for yourself also. You don't have to be as slow, as inefficient as me when it comes to reading. I'm sure you guys can read things faster than me. So that is how you'll actually save time. So even if you're not compromising on your approach to read the question, make sure that you're saving time by reading it faster than me. Okay? Okay, let's pick up one more. Are you good to go to the next question? Everybody okay? At least one yes, apart from Praneeth. Are we good to go? Okay. Next question is, in order to connect to the internet, dedicated computers are kept in a server room. In order to connect to the internet, dedicated computers are kept in a server room. Okay, interesting. To prevent overheating, the density of computers in a server room must not exceed 2.1 computers per cubic foot. I'm reading it again. In order to connect to the internet, dedicated computers are kept in a server room. Okay, this is my server room. See, you can be as stupid as me. Keep drawing things, when you are thinking about it. This is my server room, let's say, where I'm keeping computers. To prevent heating, the density of computers in the server room must not exceed 2.1 computer per cubic feet. Now it says 1 meter is about 3.28 feet. This is the information given. Which of the following densities is equal to the maximum number of computers per cubic meter? So this is a pure play unit conversion problem. Okay. Now I'm reading the question one more time. In order to connect to the internet, dedicated computers are kept in a server room. To prevent overheating, the density of computers in a server room must not exceed 2.1 computers per cubic foot. 2.1 computers per cubic foot. 1 meter is equal to 3.28 feet. So you don't really have to remember the conversion between metric system and the US customary system. Which of the following densities is equal to maximum number of computers per cubic meter? So you are given the density in cubic feet. You have been asked to find out the density in cubic meter. Which of the following density is equal to the maximum number of computers per cubic meter? So you know how many computers per cubic meter you can keep in the server room to avoid overheating. Now you have to find out, if you have to think about it in meters, how many it would be, and you are given the conversion rule. The options given are 0.06, I'll just write a C for computer, C cubic computer or comp per cubic meter. This is A. Second option is 0.64 computer per cubic meter. Third one is 6.89 computer per cubic meter, same thing. D is 74.10 computer per cubic meters. Now, one last time I'll read it and then I'll let you guys deal with it. In order to connect to the internet, dedicated computers are kept in a server room. To prevent overheating, the density of the computers in a server room must not exceed 2.1 computer per cubic feet or cubic foot. 1 meter is about 3.28 feet. Which of the following density is equal to the maximum number of computers per cubic meter? So you are given the density, you have to convert that into a different unit. That is number of computers that you can keep in the server room per cubic meter. Everybody heard the question loud and clear so many times. I will let you guys deal with it and tell me what is the answer, and then this is one of the easiest problem to deal with, but this is one of the most mistake prone problem, if I can say so. So just be careful. And I'll give you guys a very easy method for solving it. If I see anybody scratching his or her head, there's no girl right now in the class, so when I see everybody, no, Sarah is there. So Sarah, as soon as Sarah heard there's no girl in the class, she dropped. Yes, Sarah, sorry beta. I said there's no girl in the class, but then I realized Sarah is there.
I actually exited out by accident.
No worries, no worries. So everybody heard the question. I'm assuming that you guys are giving it a shot, right? I'll give you guys 2 minutes to solve it, 2 more minutes, and then come back to you guys again. Let's see who are ready. You got the answer?
I got C.
You got C?
Mm-hmm.
I heard a A also. That makes me happy because this is called unity in diversity. I mean, again, no jokes. I mean, it just makes me happy that okay, there are 2 different ways the problem is approached, and we'll figure out. We'll make sure that all the solutions converge to one answer, and that has been the case. So okay. Anybody else? Chris, Neil, Vishal, Sarah, Deep, Dev, Rehan. I mean, is it okay to assume that everybody is giving it a try? Whoever doesn't say anything, I'll be worried.
I think it's C.
You got C. Okay. How about you, Rehan? Vishal? Chris? Dave?
I think it's C as well.
Okay. Dave, how about you, beta?
I also just got C right now.
Okay. I'm sorry?
I also got C right now.
Okay. Vishal, how about you?
C.
C. How
I'm
about
not
you?
sure which is C and A.
Okay. Okay.
I think it's C.
Okay. That's why I keep telling you guys, don't trust your friend, because when you see that one of your friend has got A, one of your friend has got C, and you got one answer, then that makes you think that did I make something? But yeah, okay. How about you, Rehan?
I got C.
Okay. Deep, how about you? You also got C. I can hear you with a very feeble voice.
Yeah, before I was saying my answer and like no one could get. I don't know why.
Yeah, no. Nobody's ignoring you for sure, but not me, 100%.
That's why I left the meeting.
Okay. No, but you can hear me okay, right?
No, I can hear you fine.
Okay. Something to do with your microphone, where your ear part is okay, your mouth part is having problems. Okay.
I'm on my school iPad. It's probably
Okay. So yeah, Praneet, did you check? Are you still leaning towards A or you're more leaning towards C? C. Okay. So everybody got the question. I'm just giving it a shot, and probably I will do that in a way. Okay. Before I do tell my approach, does anybody in the class want to explain me how did you get C or A, whatever it was? What was your approach? Just give me the approach, not the calculation part. Benjamin, you want to give it a shot?
I already gave you the answer.
Okay.
C.
C is the answer. But just tell me the approach. I mean, what went in your mind when you were trying to solve it?
I multiplied 2.1 into 3.28 to get 6.89.
Okay. How about you, Vishal?
What?
What was your approach? How did you get to C?
I did 2.1 times 3.28 because to convert feet into meters. That's what I got.
Okay. Now, let me give you a very lame approach for solving this problem. Okay. I will use simple calculation. Okay. I will try to keep aside my brain and then see what is the answer I'm getting to. The question says that computers are kept in a server room to connect to internet. That has nothing to do with math. That is just the story part of it. What it says is to avoid heating, because if you are keeping too many computers in a room, they they emit radiations, energy, heat, right? You would have seen in the back of the laptop or the computer there is a fan that keeps on rotating and that keeps on emitting heat. So it says that okay, you cannot kind of clutter a server room with too many computers. You have to follow this density. So it says that you can have 2.1 computers per cubic feet, per feet cube. Yeah. The question is, if I am talking in feet, meaning per cubic feet I can keep this many computers. How many computers I can keep per cubic meter? Okay. Now, what I will do is, look at this. This many computers per feet. Now, this is, can I say feet equal to 1 feet? It's okay, right? Or 1 foot, whatever you call it. So, in this same formula, I will write this as, okay, this means 2.1 computer per 1 feet or 1 foot cube. Now, every feet or every foot is equal to how many meters? Look at this. What we are trying to find out, how many computers, it's not 2, how many computers per meter cube. This is what I am trying to find out, correct? Or how many computers per 1 meter cube. This is what I am trying to find out. I will not break my head to find that out. what I will do instead is, I will, in place of 1 feet, I will find out what is the equivalent of 1 foot in meter and put that here. Now, 3.28 feet is equal to 1 meter. Correct? 1 foot is equal to 1 by 3.28 meter. Agreed? Now I'll take this value and plug in here so that I don't have to worry about per 1 foot. This is my value of 1 foot. I will say 1 by 3.28 meter. Okay? Life makes a complete circle, or it's going upside down. Now here, now look at this. 1 by 3.28 meter cube is nothing but 1 by 3.28 cube into meter cube. Okay? That means this 3 point, if I am putting it here, I can write this. Okay, let me clear this little bit. So now remember this is what we have. I will use this and create some real estate here. Now this becomes 3.28 cube. So this becomes 2.1 in computed divided by 1 by 3.28 cube into meter cube, and everything is the denominator. Okay, right now. So this becomes 3.28 cube. This whole thing goes up. This becomes 2.1 into 3.28 cube of computed divided by, or per divided by whatever you call it, meter cube. So your answer would be 3.28 cube. Okay, it will be, I'm just, since I have multiple choice question, I'm not going to do exact calculation, but this is certainly more than 3. Even if I count this as 3, cube of 3 is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. 27 if I multiply by 2, it gives me 54. I have 3.28. So it's going to be more than 54 for sure. Which value is more than 54? I did not mean to prove anybody wrong, but I'm saying that this is how you are making a complex problem look simpler. I did not apply any thought, okay? I said, okay, I'm given the conversion formula. Foot I can write as 1 foot. Dollar I can interpret as $1. Okay? Same thing. What is the value of that 1 foot? I have 1 meter equal to 3.28 foot. That means in 1 meter you will have 3.28 feet. If you're talking, now imagine this one. As soon as I heard C or A, I knew that we are going in the wrong direction. We were not taking care of the conversion part. Imagine this thing, okay? 1 cubic foot, you're talking about 1 foot length, 1 foot width, 1 foot height. 1 cubic meter, meter is this big. If you can see both ends of my hand, at least this much. 1 by 1 by 1. You're talking about a much bigger volume. You're talking about much bigger space. 1 foot, 1 meter is 3 times the foot, right? 3.28, that's what is given. So you're talking about 3 times 3 times 3, that means that much size. Correct? So that is how this thing is changing. So there are 2 parts to it, okay? As soon as you get an answer, like let's say if I got this, I have to imagine, okay, foot is bigger or meter is bigger, okay, meter is bigger. I know, I can see it. How big? Are they this big versus this big? No, I see this big versus this big. And then 3 dimensions, getting multiplied 3 times. That is how my answer would change. So I did not put that much thought even, trust me. I said, okay, fine. I read the question, I know what the question is asking. It's asking me, okay, in per cubic feet this many, then per cubic meter how many? Okay. So if I convert wherever I have feet, convert that to meter, what will that be? I just converted that to meter. I kept meter in the denominator, so this whatever comes here, this many computers per meter cube. I took the numbers upstairs, right? I mean, when you have 1 by 4, this becomes 1 into 4 goes up, 1 comes down, okay? That's what happens here. Is this solution or approach convincing, or you guys want to contest? And it's okay to contest, okay? I might go wrong. I still want to hear if there's something that you are not able to understand, or if there's something that you believe where I'm going wrong. Vishal, Dhanvin, Rehan, Dev, anybody? Neil, Sarah, Deep, Chris. Guys, I'm not a scary person for sure, okay? I scold the kids, those are tiny ones, because no, they don't listen, they keep on forgetting. You guys are grown up, so I have never been rude or I never raise voice, right? So I'm not scary for sure. You can always argue with me, because I want you guys to have a very firm approach towards the concept part of it. So I'm just curious to know if whatever I did, is that understandable or not? Or if this you feel that there's something that I'm missing.
It's understandable, sir.
Okay. Pranit, is it making sense? Vishal, Neil, Sarah, Dev, Dhanvin. Dhanvin is taking time. Is this understandable? Okay?
Yes, sir.
Okay. So that was the thing, right? I mean, word problems are actually meant to confuse us with the amount of substance that they add in the question. Solving is not a big deal. I have not done anything magical here for sure. But then, how we approach them, how do we interpret them, how do we extract the information from the word problem, that will dictate or determine whether we'll get the right answer or something different. Okay? I'm not going to beat down this type of problem more, because ultimately you guys know that, okay, how you're going to approach, okay? Beat unit conversion, beat anything related to that topic. Approach remains the same. Read the question a couple of times and then the A part. See, now you would have observed that this A part plays an important role. If you get 0.6 versus 6.6 versus 660.2, you have to also do a backward thinking that, okay, this question, which is bigger, foot or meter? Yeah, I have the information that, okay, my meter is bigger. So if I'm talking about a bigger volume, obviously I'll have more. So I cannot go to 0.06, that option is ruled out. Now, is there a big difference between meter and foot, or is there a small difference? If there's a small difference, then probably I can go to 6.5 maybe. If it's a big difference, then these are different interpretations that you will draw or derive based on how you approach the problem, what are the thoughts that you put around the question, okay? So make sure that you don't do that, don't do any problem with any sense of hurry. Hurry is my neighbor. Okay. So don't do it with a sense of hurry. That was a bad joke, I know. But make sure that you just convince yourself that, okay, whatever I have done, is that what I am 100% aligning with? If you ask that question to yourself, and those things will take hardly 2-3 seconds, okay? So, yeah. So this was on the unit conversion. Let's go to the next topic, which is on percentage. And again, you guys will think that this old man is getting older ahead of time. We learned percentage long time ago, right? But my gray hairs do count. Coming back to a serious discussion, we are not going to focus on the basic concept. We'll be focusing on some of the word problems, the interesting twisted word problems that we need to practice, and what are the kind of problems that we need to deal with. That's what we'll see in the next 15-20 minutes. So percentage, everybody knows. I will not take more than 2 minutes to redo that concept part of it. Percent. Percent. Per hundred. Per and cent is 100. Cent is a short form of century, okay? And century stands for 100. Everybody is following the IPL if you are watching IPL at all. So cents is a short form of century. Per 100. Now if I say 20%, 20%. Now it becomes English. Okay? I see somebody has joined ahead of time, and that is Mandeep. Mandeep, you'll be scared with, okay? Next 15 minutes, I am going to talk about a lot of scary stuff, which is for 10th graders, 10th, 11th graders. So you might want to join for 15 minutes, okay? Mandeep, you joined a little early. Alright? I mean, you can listen, but make sure that you are not getting scared. Alright. Coming back to, when you say percent is per century, per 100. If I say, I'll give you 20% discount, what I'm actually talking about is 20 per 100. Meaning, if you are talking about anything which is 100, I'll give you 20 discount. Meaning, you'll have, instead of 100, you have to pay 100 minus 20. Yeah? So, that is the basic interpretation. Let me not go into that. I'm assuming that you guys know what is a percentage, and I'm not double clicking on that now, unless we see that there is something that we are missing when we are trying to solve the problem. Let's pick up a few problems and see what is the level of complexity we are dealing with. So let me pick up another problem for you guys on percentage. I mean, first problem, let's say. Okay. Today, Ebuka opened a new cereal box. He ate a bowl of the cereal, which was 8% of the cereal in the entire box. Approximately how many more bowls of cereal can Ebuka expect to get from this box if he continues to eat the same amount of cereal in each bowl? Reading the question one more time. Today Ebuka, let's say it's not Ebuka, it's Biren, doesn't matter. Today Biren opened a new cereal box. This is my cereal box. Okay. In the cereal box. Today Biren opened a new cereal box. He ate a bowl of the cereal. This was the bowl. He ate a bowl of the cereal which was 8% of the cereal in the entire box. Whatever was the amount of cereal in the box, he took a bowl of it, and that was apparently 8% of the total cereal in the box. Approximately how many more bowls of cereal can Biren expect to get from this box if he continues to eat the same amount of cereal in each bowl? Any answer on this one? So we have 4 options. Let me put the options also for you guys. 7 bowls. Second one is 8 bowls. Third one is 11.5 volts, and fourth one is 12.5 volts. What do you guys think?
Can you read the question one more time?
So today I opened a cereal box, okay, and ate one bowl of the cereal. Ate one bowl of cereal, okay, and that one bowl was 8%. Okay. So if every time I pick a bowl of cereal, it's approximately the same amount. So how many such bowls of cereal I can have from this box? That's the question. And these are the 4 options that we have. I got one answer, and now I'm keeping my mouth shut to let you guys try. Everybody heard the question, right? Now I'm assuming that there's no doubt about the question at least, right?
Can you say the question again?
Okay. Today, Ebuka opened a new cereal box. He ate a bowl of the cereal, which was 8% of the cereal in the box. Approximately how many more bowls of cereal can Ebuka expect to get from this box if he continues to eat the same amount of cereal in each bowl? So approximately how many more bowls of cereal can Ebuka expect to get from this box if he continues to eat the same amount of cereal in each bowl? Yes, Vishal.
I got 11.5.
Okay. I got 2 answers and they are different, and that is a good thing actually. How many more bowls? Okay, you got the clue. I was giving you the clue. Okay. I'm assuming everybody got the question and you guys are trying it. I'll give you guys 1 more minute because I want to solve one more problem. This was probably an easy one, and I want to try something little more loaded than this one. You guys said this is not D.
D.
You think it's D? Okay. Any other answer? My neighbors are very friendly. Okay, so I heard 3 answers so far. I heard 1D and 2C. Anybody else? Chris, Dhanvin, Deep, Neil, Rehan. Did everybody hear the question clearly? Dave? Okay. So let me, okay, anybody else want to give an answer before I bore you guys with my stuff? Okay, let me try that. So the question says, somebody opened a new cereal box and ate 1 bowl of cereal from the box, which was approximately 8%. 1 bowl was 8%. So out of 100, if let's say there were 100 cereals in the box, one bowl took 8 out of it. 8 out of 100. 8 per 100. If he takes 2 bowls, he is eating 16 out of 100. And if he eats 4 bowls, he is eating 32 out of 100, 32%. So you are trying to find out how many bowls he can eat to finish it up. So eight percent is 1 bowl. 1% will be what? 1 by 8 bowls. 100% will be what? Whatever the value for 1, multiply that by 100. That gives you 12.5. And this is where you will lean towards D. But there was one catch in the question. It says, how many more bowls? It says that somebody has eaten 1 bowl. How many more bowls? Meaning, after having eaten 8%, what is that you are left with? So total number of bowls from 0 to 100 is 12.5. He has already eaten 1 bowl. So what you will have is 11.5. So those small words in between, they are the catch. How many more bowls? Even if I were you, I would have probably gotten this answer as well. But then, when I read the question a couple of times, I realized there is a one hidden word. How many more? After eating 1 bowl, how many more? So that is when we will take 1 out of 12.5 and then this will become your answer. We have, how much time? We have 5 more minutes. Let me read the next question and see if you are able to solve it within the time. An empty pool has the capacity to hold 2700 cubic feet. Empty pool has the capacity to hold 2700 cubic feet of water. So empty pool, this is my pool. I don't know whether it looks like a pool or a container. This can hold 2700 cubic feet. So cubic feet of water. A particular hose fills this pool with water at a rate of 12. A particular hose fills the pool with water at a rate 25 cubic feet per minute. If the hose is placed into the empty pool and turned on, approximately what percent of pool will be filled with water after 1 hour? So this is the pool, has a capacity of 2700 cubic feet. The hose fills the tank at 25 cubic feet per minute. If the hose is kept in the empty pool for 1 hour, what percentage of the pool will be filled? And the options you have are 10%, 44%, 56%, and 93%. Okay? So I see the kids from the next class have also started joining. So Sammy, Mandeep and Ananya, Aditya, just hold it for 5 more minutes, okay? We'll wrap up this class. Yep, inshallah. The question says, there's a pool with the capacity 2700 cubic feet. A hose can fill the tank with 25 cubic feet per minute. If the hose is kept in the empty pool for 1 hour, what percentage of the pool will be filled in 1 hour?
Is it 700? Did you say 700?
This is 2700.
Okay.
No, not the chair. That chair is not good. You leave the chair. That chair is not for kids.
Can you say the question one more
Leave the chair, you take the other hard one. That chair is not for kids. Yeah. The question is, there's an empty pool with there's a pool of capacity 2700 cubic feet. A hose can fill the pool at a rate of 25 cubic feet per minute. If the hose is kept on for 1 hour, what percentage of the pool will be filled?
I got C.
See?
I got the third answer.
Okay. How about you, Puneet? You got B. Okay. Okay, guys, don't make any sound. The class is still going on. Okay. So here's the deal. The question is very simple, okay? You know that the capacity of the pool is 27 cubic feet, 2700 cubic feet. Meaning, once I fill this much water, it will be 100%. Now, we are keeping the hose on for 1 hour. How much water I am putting in the pool? Every minute I am pouring in 25 cubic feet. That is per minute. So if I am keeping it on for 1 hour, that means I am pouring this much water. And that will be 25 times 60. 25 times 6 is 150. 1500 cubic feet is what I am filling. What you have to find out is, I have filled 1500 cubic feet out of 2700. So that is what percentage? So 1500 is what percentage of 2700? That is what you have to find out. So these two you can knock off. This is 3 5 are 15. This is 3 9 are 27. So 500 by 9. 9 5 are 45. 5 0. 9 6 are 5 0. 9 5 45 5 0. 9 6 are no. 9 5 are 45. Then 5. So yeah, close to 56%. Yep. So Vishal, you are right. So we will probably try few more problems tomorrow. Again, those are word problems, nothing new for you guys to learn with respect to percentage, but life keeps on getting more interesting when we deal with word problems. So that's what we'll try solving few of them tomorrow, and then we will go to the next chapter. Alright? With that being said, I will let you guys go.